So today we will continue with monomial greatest common factor top level exercises. So it's going to be the same type of exercises. The only thing is we are going to use bigger numbers, maybe a little bit difficult for doing the prime decomposition. But let's see. The steps we know that are first we need to find the coefficient common factor that it's going to be using prime decomposition, finding the greatest common divisor of all the numbers. Then we will find the highest common power of all the variables. It says here smallest power of all common letters. That will mean in this case we have x to the 5, x squared, and x cubed. So in this case, the greatest common or the highest common power will be x squared, that is the smallest one of all the letters x. So that's why it says smallest power of all common letters. Then it says to use the distributed property, that means putting the parentheses and dividing or looking how to obtain the terms in the polynomial. And at the end, we will need to order our answers. Remember, we can do the ordering at the beginning, ordering the polynomial, or we can do the ordering at the end, ordering what it's inside the parentheses. So that's up to you. So let's see. In this case, I will do the ordering first. The correct order will be 306 x to the 5, y to the 4, c cubed, plus 510 x cubed, y cubed, c to the 7, minus 204 x squared, y to the 5, c squared. Then we will need to use prime decomposition. So we have 306, 510, 204. So you start doing the prime decomposition. We can divide every term by 2. It's going to be 153, 255, 102. Then we can continue with number 2, but that number 2 only divides the last one, so it won't be circled. It will be 51. Then we can do division by 3. All of them will be divisible by 3. So let's see. The first one will be 51. The second one is going to be 255 over 3. It will be 85. And finally, it will be 51 divided by 3, it's 17. Then with 85 and 51 are divisible by 3, but not this 17, so it's going to be 17. It's going to be 85 divided by 3. It's not divisible by 3. So that's not divisible by 3. So it will stay the same. 85, 17. Then we can divide 85 by 5. And it's going to be 17. And finally, we can divide every term by 17. So here, the common power, the coefficient common factor will be 17 times 3 times 2. That's going to be 17 times 6. So if we multiply 17 times 6, it will be 102. So here it's going to be 102. Then we need to look for the letters. In this case, x, we have x to the 5, x to the third, x squared. So the biggest common power is x squared, because x cubed to the cubed, it's composed by x squared multiplied by x. And x to the 5, it's composed by x squared multiplied by x cubed. So it's going to be x squared. Then in the case of y, we have y to the 4, y to the third, y to the 5th. So it will be y to the third. In the case of c, we have a c cubed, c to the 7, c squared. So it's going to be the smallest one, c squared. Then I open the parentheses to use the distributed property. And it's going to be 102 multiplied by 3 is 306. X cubed, x squared to be x to the 5, we need x cubed. Y cubed to be y fourth, we need a y. C squared to become c to the cubed, we need a c. Then it will be plus 5. X squared to become x cubed, it's going to be x. Y cubed to become y cubed, we don't need it. C squared to become c to the 7, we need 5 of them, c to the 5. Finally, minus 2. And in this case, it's going to be x squared. It's correct. We don't need anything. Y, we need y squared. C squared, we don't need anything. So it will be like this. And this is going to be our actual correct and ordered answer. So let's see another example. So let's see, in this exercise, we have also big numbers, 303, 505, 606, and 202. So in this case, it's the same. We can order at the beginning, we can order at the end. I will do the ordering at the beginning, so it will be 606, a to the 8, b to the third, c to the 5. Then it's going to be plus 303, a to the 7, b to the 5, c to the 12, minus 505, a to the 6, b to the third, c to the 7, minus 202, a to the 5th, b to the 7, c squared. So we need to do the prime decomposition of the numbers. 606, 303, 505, 202. So we can start dividing by number 2. It's going to be 101. This cannot be divisible by 2. This one also is not divisible by 2. This one is going to be 303. Then we can continue with number 3. So it's going to be 101, 101, 505, 101. Then we can continue dividing by 5. Then, of course, we need to continue with 101. So if we remember, prime numbers are those that are only divisible by 1 and themselves. In this case, 101 it's a prime number, so we need to divide it by 101. That will be the only factor that was common for all of them. So it's going to be 101. Then we go with the letters. We have a to the 8, a to the 7, a to the 6, a to the 5. So the biggest one that it's common, it's a to the 5, because a to the 6 is composed by a to the 5 multiplied by a. A to the 7, it's a to the 5 multiplied by a squared. And a to the 8, it's a to the 5 multiplied by a to the third. So it's going to be a to the 5. Then with b, it's going to be the smallest one. We have b cubed, b5, b cubed, b7. So it's going to be b cubed. Then in the case of c, we have c to the 5, c to the 12, c to the 7, c squared. So it's going to be c squared. Then I open the parentheses and let's see. For 101 to become 606, we need 6. The coefficient, the letters a to the 5 to become a to the 8, a cubed, b to the third to become b to the third, we don't need anything. C squared to become c to the 5, we need 3 of them, c cubed. Then it's going to be plus 3. A to the 5 to become a to the 7, we need 2 of them. B to the third to become b to the 5, we need 2 of them. C squared to become c to the 12, we need 10 of them. C to the 10 minus 5. A to the 5 to become a to the 6, we need only one a. B cubed to become b cubed, it's the same. C squared to become c to the 7, we need c to the 5. Then it's going to be minus 2. A to the 5 to become a to the 5, we don't need anything. B cubed to become b to the 7, we need b to the 4. And c squared to become c squared, we don't need anything, so we close the parentheses. And this is going to be our actual final answer. So as we saw, it's the same to do monomial greatest common factor with smallest number and with bigger numbers. The only part that will change a little bit will be the prime decomposition, that maybe can be a little harder to do. So now you can start working on top level activity of greatest common factor.